Hello, welcome you all for this video lecturing on LCD interface with 8051. Today we shall understand how a LCD can be interfaced with 8051 microcontroller. In this class, I shall cover why LCD needs interface, pins of LCD unit, LCD module commands, interface circuit diagram and sample programs. So you can see on your screen the LCD display unit which is going this is the display unit which is going to be interfaced with microcontroller. And before we start on what this LCD screen is, we shall try to understand why is that this LCD screen why is this LCD unit needs to be interfaced with microcontroller. See here, any data that needs to be displayed on this LCD screen, that data has to be sent through one of the processor, and also to control all the commands of how or even to configure the LCD, one of the processor is required. Therefore, the LCD screen or a LCD unit cannot be a standalone unit. A data needs to be sent to it through one of the processor or through one of the controller. Therefore, LCD cannot be used as a standalone unit. It needs to be interfaced either with a microprocessor or with a microcontroller or with any other processor for that matter. So that is the reason why LCD interface has to happen if LCD needs to be used. So we shall look into this LCD screen, LCD unit. You can see that it's a two lines are there. Both the lines have 16 boxes, and in each of these 16 boxes a single character can be displayed, and each of these boxes are of matrix pixel size 7 cross 5 or 8 cross 5, 5 cross 8 or 5 cross 7 pixel matrix size. Okay, so this is about the screen which we would want to LCD unit which we would want to interface with microcontroller. And also we can see that this particular unit has 16 pins. Now we shall understand which are these pins of LCD unit. You can see on your screen that it has 16 pins, and amongst these 16 pins, 8 of the pins are data pins. Means the data that has to come from the processor will be accepted through these data pins. DB0 to DB7 are the 8 data pins which accepts the data from the microcontroller, and therefore 8-bit data lines or 8-bit pins are available in this particular unit. Apart from this, there are three more units. There are three more signals you can see: VSS, VCC, VEE. VSS and VCC accordingly are the ground and plus 5 volts which is required for any of the digital device to operate, and therefore plus 5 volts with respect to ground is supplied through VCC and VSS. You can look at one more pin, VEE, or in a display you saw it as a V0. This particular pin is actually a contrast adjustment pin. Means to say that the brightness of the display can be adjusted with respect to this particular pin. This pin is basically going to be connected to a pot resistance, and if that resistance is varied, the voltage varies from 0 volts to 5 volts, thereby changing the brightness of the display unit. So that provision is available in this particular LCD unit. Apart from that, you can even see there are pin number 4, 5 and 6. These pin number 4, 5, 6 are RS pin, R bar W pin and enable pin, E pin. These three pins are the pins which are required to configure the interface. If you would want to command, or if you would want to control the interface between microcontroller and the LCD unit, these are the three lines through which the microcontroller gets interfaced and controls the LCD unit. What are these register select? What is this read bar write and enable pin? We'll look at the later point of time. Apart from that, there are two more pins, which is LED plus and LED minus, pin number 15 and pin number 16, which are usually a backlight LED, positive and negative lines, which are not much concerned here at this point of time. Okay, this is about the 16 pins that are there in LCD unit. Next, we'll get into the various commands that this particular LCD can be given with. See, dear students, whenever you would want to interface microcontroller with whenever you would want to interface microcontroller with LCD unit, the LCD unit works in two phases. First, you need to configure the LCD unit and then display the data that you would want to display on it. So two phases. In first phase, you will configure the LCD. In the second phase, you will send that data and the LCD unit will display that particular data. Fine. So in this first phase, the configuring of LCD takes place through the commands. Microcontroller has to give the commands to the LCD unit so that it gets configured. Then the question arises, like what all commands can be sent to a LCD unit? You can see on your screen that there are commands which are listed out: 0FH, 01H, 02H, 04H. These are the various LCD commands that one can give, means the microcontroller can give to a LCD unit. And what does it mean? See, these commands are hexadecimal 8-bit commands. Please remember, these commands are 8-bit hexadecimal commands which are given from microcontroller to a LCD unit. See, if 0FH is given, then LCD will put on, cursor on, and cursor starts blinking. Three things happen if you send this particular command. If you send 0FH, it gets configured in such a way that LCD is put on, cursor is put on, and that cursor starts blinking also, right? So if you send 01H to a LCD as a command, then it clears the screen. If the previously displayed data is there, it gets erased. So similarly, if you would want to increment the cursor after one character display, then you will have to write 06H, increment cursor. 04H, if you send, it will decrement the cursor. Means here, when the cursor is defined, the cursor can be defined on the left side or the cursor can be defined on the right side. Then will the cursor move from right side to left side? Because there are 16 boxes to be displayed. From right to left we will go, or from left to right we will go. Like this, there are various configuration that needs to be set into the LCD before you display a data. One of the important thing that you need to do is send 38H command, which uses both the lines, and it will use each box of size 5x7 matrix pixels. Okay, so the basic things that you are supposed to send as a command, I'll just read it out: 38H, 0FH, and 06H. These are the minimum 3 basic commands that you need to send to a LCD unit so as to configure that LCD unit. So the first thing, the first phase is to configure the LCD, right? Then after configuring the LCD, how to display a data on that particular LCD? To look at that, we shall see how to send commands and data for a display. See here, I have already told you that there are 3 control pins that is RS, R bar W and E pin. RS pin stands for register select. See, whenever the data, 8-bit data is sent from microcontroller to a LCD unit, that data will be either the command or that data will be the data which needs to be displayed. So the LCD should get to know whether the data which is sent, is it a command or is it a data to be displayed. This particular signal RS from the microcontroller will tell the LCD whether the data, 8-bit data which is sent, is it a code, is it a command or is it the data to be displayed. Then what is this RS? RS is register select, means this particular LCD unit will have two registers in it. One is called as command register, another one is called as data register. Whatever data it stores into a command register, once it is stored into a command register, inside the command register it automatically executes that particular 8-bit command. So if you want to execute a command in LCD, what you should do? You should send that command to a LCD unit, and once that LCD unit receives that data from DB0 to DB7, it will store it in a command register, and once it is stored in a command register, the command gets executed inside that command register, right? That is one probability. Second probability is the data that you have sent might be a data that you would want to display. In that case, what happens is the data which has come gets stored in a data register, and once it gets stored in a data register of LCD, it gets automatically displayed with a given configuration. So RS is the signal which comes from microcontroller to a LCD unit, and whenever LCD unit receives a 8-bit data, it waits for RS to come from the microcontroller. It looks at RS and then decides based on the value of RS, register select. If register select is 0 sent by the microcontroller, it means that it is a command register. The data which is sent is a command, and that particular data needs to be stored in a command register. So upon receiving 0 on RS line, it will store the data into a command register. If RS is 1, then LCD will get to know that the data which has come needs to be displayed, and it will store that data into a data register. So the LCD will decide whether the 8-bit data which it has received from the microcontroller needs to be stored either in a data register or in a command register. If RS signal that it has received from the microcontroller is 0, then it stores the data in command register. If RS is 1, then it stores the data in data register. Fine. So that is about RS pin. Next one is read bar write pin. See here, whenever the microcontroller and the LCD is interfaced, the data can be exchanged on both the sides. 8-bit data lines are there and data can be exchanged from both the sides. And if the data flows from microcontroller to a LCD, we call it as a write process. And if the data flows from the LCD into a microcontroller, then it is microcontroller reading that data. We call it as read. Occasionally this read signal is used. At this point of time we don't want to look into that. So by default for you people in the interface, all the time it is the microcontroller which sends the data. That data could be a command or a display data, but it is always that microcontroller sends the data, therefore this particular signal R bar W should be 0. So R bar W will be 0, right? Apart from that, you have one more signal called as E, enable signal. This is one more pin, control pin that is available in LCD. This E pin will enable the LCD. See here, whenever the interface has to happen, the microcontroller or the processor, whenever it gets interfaced with the external device, it has to activate the external device first and then start doing a and then start sending the data with it. Okay, so how to activate this external device? In this case, the LCD device, it will send 0 on enable pin, it will send a high to low going pulse. Means first it will send 1, then it will send 0, and then it will create a delay. Means a high to low going pulse needs to be generated on this pin E, then only the LCD gets enabled. Okay, so these are the three things that needs to be configured before either you send the command or the data to be displayed. Fine. So hope you have understood this. Now we'll get into the circuit diagram. You can have a look at the circuit diagram. We shall not look into the other side of the microcontroller. We shall only look into the interface lines that have taken place between LCD and the microcontroller. I said that DB0 to DB7 are the 8 data lines which are there with the LCD module. These lines are connected through port 1. You can observe that port 1.0 to port 1.7 is respectively connected to DB0 to DB7 of the LCD module. So what it means? It means that whenever the microcontroller would want to send either the command or the data to be displayed, it has to send that particular data through port 1. And where will it get received? It gets received at DB0 to DB7. Fine. So that is 8-bit interface that has taken place, data line interface. Apart from that, I said that there are 3 control lines: control line E, control line R bar W, control line RS on the LCD module side. Those lines are connected to, if you can see, those lines are connected to P3.3, P3.4 and P3.5. That is port 3, 3 pins of the port 3 pin is connected to a control lines. So whatever you send on P3.5 will be received as a register select. So if P3.5 is 0, what it means? If you send 0 on P3.5, it means that the data that you will be sending from port 1 will be a command, and that particular data which is received at DB0 to DB7 now gets stored in a command register. If P3.5 pin is 1, means to say that you are sending 1 logic high into RS pin. In this case, what happens? The data which is sent from port 1 is nothing but a display data. Therefore, the data which is received at DB0 to DB7 from port 1, that data will get stored in data register, and once it is stored in data register, it gets displayed on the display unit. Isn't it? So simple it is. See here, 8 pins from port 1 connected to 8 pins of data lines of LCD, and 3 pins P3.5, P3.4 and P3.3 are connected to the control lines of LCD. So coming on to P3.4, P3.4 you can observe that it is connected to R/W signal, read bar write signal, and this has to be all the time 0. This has to be all the time 0. Therefore, when you send 0 on this particular line, it says that microcontroller is writing the data through port 1 into the lines DB0 to DB7. So DB0 to DB7 will only accept the data. Port 1.0 to port 1.7 will only send the data. Other way is not possible, right? Next, P3.3 is the signal which is connected to pin E. Pin E is a enable pin. Therefore, first on P3.3 you will have to send high, immediately you will have to send low, and then generate a delay. That will create a high to low going pulse. So once high to low going pulse is detected on pin E, the LCD gets activated, enabled. Okay, so this is about the overall interface diagram. Apart from that, you can see that VEE is having a port, and it is used for adjusting the brightness of the LCD display unit. VSS and VCC are respectively ground and plus 5 volts that you will be using. Fine. So this is about the circuit diagram. We'll next get into the program to understand how actually the program can be written. Okay, fine. We'll get into the program. What we are supposed to do, I have already explained to you. What we need to do is simply send the data to a LCD unit, and once we send the data to a LCD unit, we should also, means microcontroller should also let it know to the LCD that data sent is a command or is it a data to be displayed, right? So I have told you that it comes in two phases. First, you will have to configure the LCD, means you will have to send all the hexadecimal commands that are required to configure the LCD display. Once the LCD display is configured, then you can send the display data so that it gets displayed on the LCD, right? So that's what we have done here. You can look at the program. The program says move a comma hash 38h. What is 38h? You tell me. There I had told you that it is 2 lines 5x7 matrix. It's one of the command. So send this into accumulator and then call a function. I'm making use of a function called cmnd command. What is 38h? Is it a command or a data which we would want to display? It is a command which will make the LCD enable the 2 lines and all those boxes as 5x7 pixel boxes, isn't it? So send that data into accumulator and then call a command. A call command means when you call a call command, actually you are calling the function function routine which will actually send this data as a command data. So this data will be received by the LCD as a command. Once it receives this data as a command, it gets stored in a command register, and once it gets stored in a command register, it gets executed as a command, right? So we'll look at that command program later on, right? So 38h, I'm storing it into accumulator. I need to move it to port 1 and then call for a command control signals, right? RS I need to send, write signal I need to send, and the enable signal I need to activate, right? So that is the first command that I would want to send. Second command, I told you that 0fh, which will put on the LCD, which will put the cursor on, and also that it makes the cursor blinking, right? If you don't want that cursor blinking, there is also I think 06h, not 06h, some other command is there on the list. It is there, you can go find it. So that that particular command can also be sent instead of 0fh if you would want, right? So initially you have sent 2 commands and you are calling for a command function routine, right? Then you also send 01H, because previously if any data is already getting displayed, it will not look nice. You simply erase the screen. To erase the screen, you should send 01H to a LCD panel. So 01H also you send it as a one of the command. Then if you are sending only one 8-bit data, it's fine. If you are sending multiple data to be displayed, means if you would want to display hello, HELLO, you will have to display it in 6 boxes, in which cases each time you send the data, it needs to get incremented. It needs to move from left to right, isn't it? Therefore increment cursor has to be adjusted first. So that command needs to be sent to a LCD. So that also we will send there. 06H, we are sending it and executing that command before we start the data. And also 82H, cursor line 1, position 2. We'll start from a position 2 in a cursor line 1. It is if you would want to have like this, you can have it like this, or you can skip this particular command. It's up to you. Now if you are sending multiple data and also you want to send it on the second line, you need to activate the second line as well. So there is one more command 3CH which is sent here to activate the second line. So you are sending the series of commands so as to configure the LCD, right? So after all these things, you can see that after sending all these commands, now we are sending 49 decimal value into accumulator, and then you call, this time not the command function, but you will call a display function. What is display function? Display function will ensure that whatever 49D that you have sent on a port 1 gets into a LCD and gets stored in a data register and gets displayed on a LCD, right? So you need to write a program for that. That is written as a function here, a call disp. So disp is a display function. We'll come back and see that display function also. Similarly, 54 decimal value is sent. Again, it's a data. So I have sent 2 datas. As an example, I have sent 2 datas. If you would want if you would want to display hello, you will have to send the ASCII equivalent of HELLO. Just look into that and send those series of 6 datas and you will get a hello displayed. Okay, so now we'll look into the these functions, command functions and the display functions. The program is over now. Here jump, yes, jump here. The program is over. So outside the program we write the functions. Hope you understand that. You know how functions are written, right? So in functions, what we are supposed to do? First thing, the data or the command. Now we are looking into command, right? CMND. We have started that CMND subroutine, or that function we have started. So in that, accumulator has the command. From accumulator, send it to port 1. Why? Because port 1 will take it to the LCD, DB0 to DB8, DB7, right? So put it into port 1, and after that 3 configurations you will have to do. Which are the 3 configurations? You will have to enable the pin E, you will have to send the write command, and you will have to say in which register it should get stored. Register select has to be done. What should be register select? 3.5 is the pin which is getting connected to register select there. So what you would want to send on register select? You would want to send 0 on register select, because 0 means it selects the command register. It will get to know that the data that is sent on port 1 is the command, and it should not be stored in the data register. It should be stored in a command register, and therefore it stores it in a command register. For that you will have to clear port 3.5. okay, after that port 3.4 is getting connected to read bar write signal. Should it be read signal or write signal? It should be write signal. If it is write signal, what you should send? You should send 0 on that line. So therefore clear the content of P3.4 so that 0 will go to a read bar write signal on LCD panel. Fine. After that, you should enable the signal. You should send the enable signal to a E pin. E pin is connected where? To P3.3. What should happen now? I told you, you should send first high signal, then low signal, followed by delay signal. Remember? Okay. See here. First I am setting P3.3, means high signal I am sending. Then I am clearing P3.3 so that I am sending the low signal. So pulse will fall from high to low. And then I'll call it delay. Delay will sustain that to a level. Low level is sustained now. So when this signal is received by pin E of the LCD, LCD gets enabled. So whatever is there in port 1, what was there in port 1 first? Tell me what was there in port 1? What you had sent in port 1 first? 38H. 38H was copied into accumulator, and from accumulator you have copied into port 1. So 38H has now gone to the command register and it gets executed there as a command. Fine. After that, again 0FH is executed as a command, 06 is executed as a command, 01H is executed as a command, 82H is executed as a command. After all these series of commands are executed, the LCD is configured. Then I am sending the data. What was the data that we had sent to display? I'll just see it back. It is 49 in decimal and 54 in decimal, and then we had called the routine, subroutine called disp. So what should disp do? It should take the accumulator content into port 1, and then this time what should be P3.5? This time P3.5, which is connecting to register select, should be 1. If it is 1, the LCD will get to know that yes, the data which is sent from port 1 is a display data, and therefore the data which it has collected from port 1 in a dB0 to dB7 it has collected there, and that data it will store it in a data register, and the moment it stores it in a data register it gets displayed onto a display unit. So you need to set P3.5. How about P3.4? You are writing the data, therefore again here also, just like command register, here also you need to clear P3.4, right? And then you need to enable E signal by sending high to low and then a delay signal. So this is how the LCD interface works. Thank you.